R is a region that's bounded on the right by the parabola y equals 4 minus x squared, above by the line y equals 1, below by the line y equals 0, the x-axis, and to the left by x equals 0, the y-axis. We're asked to set up two different iterated integrals using both possible orders of integration to evaluate this double integral. Well, our first step should be to draw the region. I think you should pause the video here and construct the region, and then think about what order of integration you'd like to use if you were asked to evaluate this double integral. We're going to have to do both, but see if you can pick an order that makes sense to you to start with. So I'm hoping you've drawn this region R. I've used different scales on my x and y axes because where I'm bounded by this parabola, I see this separate little region over here, but it's pretty small, and if I drew everything to the same scale, it'd be very hard to see. So we're asked to set up two different iterated integrals to evaluate this double integral. And my function was 4 minus x. All right, well, looking at this region, I hope you thought integrating with respect to x first would be a good idea. And the reason I say that is when I integrate with respect to x first, I always have the same left function and the same right function. But if I were to shoot an arrow with increasing direction of y through the region, I'll need two different integrals, and I'll have to use the additivity property, and that's fine, but maybe, just maybe, this one's easier to set up because I only need one integral to start. So that's what I'll do to begin. Integrate first with respect to x and then with respect to y. Well, I enter the region at 0 and I exit at my parabola. Well, the parabola was given to me as 4 minus x squared, so I need to do a little solving. X squared is equal to 4 minus y, and x is equal to the principal square root of 4 minus y, because assuredly I'm dealing with x's that are positive, and now I can actually think about this as a square root function, right? So there's my top bound. X equals 4 minus y, and now I need values of y that contain the whole region, every possible ray that would go through, starting at 0 and ending at 1. All right, so there is one of the iterated integrals I was asked to write down, and now we're going to have to deal with the other order of integration where I'm going to need two different integrals and where I'll have to use the additivity property. And since I already know I'm going to have to use additivity, I'm just going to go on and give myself room to write everything down. All right, so I wish I had enough room to write that here, but this plus this, I'm integrating with respect to y and then x. Well, the first part of my region ends right there. The bottom function is 0 and the top function is 1. And I start at x equals 0 and I end where I intersect, so I'd need to think about setting those equal to each other. And so x is the square root of 3. Over here, I enter the region at 0 and exit at my parabola, y equals 4 minus x squared. And then I would be starting at root 3 and ending at 2. There are my two different setups for this problem. If I met this problem in the wild, I assuredly would probably go with this, though I should be able to evaluate this. If you are watching this video as part of the Calc 3 course that it's made for, you'll find a PDF of my solution to both integrals worked out, to both setups, getting down in both cases to 235 over 12 minus 8 root 3. If you just happen to cross this video on YouTube, well, here you go, pause the screen, there's my solution. I do recommend, as an exercise, going through and evaluating both of these. But there are my solutions for now.